Hi students, exercise 1.2, first question, prove that root 5 is irrational. That is, we have to prove that root 5 is irrational. So let us suppose, let root 5 is rational. Okay, we have to suppose that root 5 is a rational number. Then we know that root 5, rational number means it is of the form a by b, where A and B are co-prime. Co-prime means there is no common factor other than 1. Co-prime integers, okay? Integers. They are co-prime integers and denominator, that is B, not equal to 0. Now squaring both sides, when you square, that is squaring both sides, we get root 5 square, that is 5, equal to a square by b square. Cross multiplying, you get a square equal to 5b square. Number this equation as 1. That means a square is a multiple of 5, isn't it? A square is a multiple of 5, or you can write a square is divisible by 5. Divisible by 5. A square is divisible by 5. Since a square is divisible by 5, we get a is divisible by 5. A square is divisible by 5 means a is divisible by 5. A is divisible by 5. Now this result as 2. Okay. Now let a equal to 5 into some number, say c. That is c, where c is an integer. C is an integer. Let us take a equal to 5c, where c is an integer. Now substituting in first equation, you get c square, that is 5 square c, 5c the whole square equal to 5b square, or we get 25c square equal to 5b square. Cancelling 5 on both sides, we get 5c square equal to b square. That means b square is a multiple of 5, or we can say that b square is divisible by 5. B square is divisible by 5. That implies b square is divisible by 5 means b is divisible by 5. B is divisible by 5. We can number this result as 3. Now from 2 and 3, we get a is divisible by 5 and b is divisible by 5 means a and b has common factor 5, isn't it? Therefore, 5 is the common factor of a and b. Both a and b having common factor 5. That is a contradiction. This contradicts the fact that a and b are co-prime. A and b are co-prime integers. A and b are co-prime integers means there is no common factor. Co-prime integers. Okay. A and b are co-prime integers. Therefore, our supposition is wrong. Hence, we get root 5 is irrational. Okay. Root 5 is irrational. Irrational. Root 5 is irrational. Once again, prove that root 5 is irrational. That's the question. Let us take root 5 is rational. Let us suppose that root 5 is rational. Then rational number means it is of the form a by b. Root 5 equal to a by b, where a and b are co-prime integers. Co-prime integers means having no common factor other than 1, where b not equal to 0. Squaring both sides, we get root 5 square that is 5 equal to a square by b square. Or when you cross multiply, you get a square equal to 5b square. Number this equation as 1. That implies a square is a multiple of 5, or we can write a square is divisible by 5. If a square is divisible by 5, then a is also divisible by 5. Number this result as 2. Let a equal to, if it is divisible by 5, then we can write a equal to 5 into c, where c is an integer. C is an integer. Okay, c is an integer. Now substituting in first equation, instead of a square, you have to write 5c the whole square, that is equal to 5b square. Squaring 25c square equal to 5b square. Cancelling 5 on both sides, we get 5c square equal to b square. That implies b square is a multiple of 5, or we can write b square is divisible by 5. That implies b is divisible by 5. This is the third result. From results 2 and 3, we get 5 is the common factor of both a and b. Okay. Therefore, 5 is a common factor of a and b. This contradicts the facts that a and b are co-prime numbers, isn't it? That implies root 5 is irrational. Okay. Prove that 3 plus 2 root 5 is irrational. That is the second question. Now we have to prove that 3 plus 2 root 5 is irrational. So let us suppose it is a rational number. Suppose 3 plus 2 root 5 is rational. Okay. Take the contradiction. That is, we have to prove that it is irrational. So suppose 3 plus 2 root 5 is rational. Then we know that 3 plus 2 root 5 is of the form a by b. Rational number means it is of the form a by b, where a and b are co-prime integers. Co-prime integers. That is, there is no common factor other than 1, having b not equal to 0. Now taking 3 to RHS, we get a by b equal to, 2 root 5. 2 root 5 equal to a by b minus 3. Dividing throughout by 2, we get root 5 equal to a by 2b minus 3 by 2. Dividing throughout by 2, we get root 5 equal to a by 2b minus 3 by 2. But we know that a, b, 3 and 2 are integers, isn't it? Are integers. All these are integers. Therefore, a by 2b minus 3 by 2 is a rational number. A by 2b minus 3 by 2 is a rational number. Because a by 2b is a rational number, 3 by 2 is also a rational number. Difference of rational number is a rational number. Hence, we get a by 2b minus 3 by 2 is a rational number. Therefore, from 1, we get root 5 is also a rational number. Root 5 is a rational number. But this contradicts the fact that root 5 is irrational. This contradicts the fact that root 5 is irrational. That is, our supposition is wrong. Therefore, we get 3 plus 2 root 5 is rational. Okay. 3 plus 2 root 5 is, irrational. Our supposition is it is rational. But here is a contradiction we get. Therefore, it is irrational. 3 plus 2 root 5 is irrational. Third question, 1 by root 2. So, suppose 1 by root 2. We have to prove that 1 by root 2 is an irrational number. Suppose 1 by root 2 is rational. 1 by root 2 is rational. Then, we have 1 by root 2 equal to, it is of the form a by b, where A and B are co-prime integers. A and B are co-prime integers. Integers with B not equal to 0. Now taking reciprocal. When you take reciprocal, we get 1 by root 2. Its reciprocal is root 2 equal to B by A. Okay, root 2 equal to B by A. You have to take here A not equal to 0 also. Root 2 equal to B by A. Okay. Now square root of 2 equal to B by A means reciprocal of a rational number is also a rational number. Therefore we get B by A is a rational number. B by A is a rational number. That is from 1 we get B by A is a rational number means root 2 is also a rational number. Root 2 is a rational number. This is a contradiction. Root 2 is a rational number. This is a contradiction. This is a contradiction. Since we know that root 2 is irrational, isn't it? Root 2 is irrational. Therefore, we get 1 by root 2 is irrational. 1 by root 2 is irrational. Okay. This contradiction shows that our supposition is wrong, or we can say that 1 by root 2 is irrational. Second question, 7 root 5. 7 root 5. So again let 7 root 5 be a rational number. Is a rational number. We have to prove that 7 root 5 is irrational. So take 7 root 5 is rational. Then we get 7 root 5 equal to, again same procedure. It's of the form A by B, where A and B are integers. A and B are integers and B not equal to 0. Denominator not equal to 0. Here it is co-prime integers. There is no common factor. Co-prime integers with the B not equal to 0. Okay. Dividing throughout by 7. Dividing throughout by 7. Dividing throughout by 7. We get 7 root 5 by 7. It is root 5 equal to A by 7B. Now we know that A, B and 7 are integers. We know that A, B and 7 are integers. That implies A by 7B is a rational number. A by 7B is a rational number. Therefore from 1, first result we get A by B is a rational number means root 5 is a rational number. Root 5 is a rational number. This is a contradiction. This is a contradiction. Since we know that root 5 is irrational. Root 5 is irrational. That implies our supposition is wrong. Our supposition is wrong means we suppose that 7 root 5 is rational. That implies 7 root 5 is irrational. Okay. 7 root 5 is irrational. Third one, 6 plus root 2. Let 6 plus root 2 be a rational number. 6 plus root 2 be a rational number. If 6 plus root 2 is a rational number, 6 plus root 2 will be of the form A by B, where A and B are co-prime numbers, co-prime integers with the b not equal to 0. Now taking 6 to RHS, we get root 2 equal to a by b minus 6. We know that a, b and 6, a, b and 6 are integers. A, b and 6 are integers. Therefore, we get a by b minus 6 is a rational number. A by b minus 6 is a rational number. Therefore, from 1 we get root 2 is a rational number. Root 2 is a rational number. Root 2 is a rational number. This contradicts the fact that root 2 is irrational, isn't it? We know that root 2 is an irrational number. This contradicts the fact that root 2 is irrational. Therefore, our supposition is wrong. Our supposition is wrong means 6 plus root 2 is irrational. 6 plus root 2 is irrational. Okay. Thank you. 6 plus root 2 is irrational. Thank you.